Hi, this is Deepa from Karpam College of Engineering. Today let's have one small introduction session on EC 3354 Signals and System. Before getting into the syllabus, let's have one small introduction session on what is signal and what is system. First let's see what is signal. A signal is a physical quantity. A signal is a physical quantity that varies with respect to time, space or any other independent variable. We can represent the signal in many places in many ways. For example, if you are representing the signal in terms of communication, it's the carrier of data. In communication, we call signal as carrier of data. The same signal, if you are representing in term of electronics, we call it as a time varying voltage. Not only in a communication, electronic signal system, even we can represent the signal biologically. When you represent your signal biologically, we can say it as a organ, how your organ is responding to the medicine. Even we are measuring in an ECG, EEG, the heartbeat rate, all this were example of your signal. That's the response of the organ. This is the definition of the signal. We can represent the signal in three different ways. One is we can represent the signal graphically. We all know the signal is a graphical representation, but we can represent the signal in three ways. One is mathematical way of representing the signal, then we can define the signal, then the graphical representation of the signal. For example, while representing your signal, you can say it as an x of t. The t is your independent variable. This is the small graphical representation of the signal. It doesn't carry any information. For example, I have given this as a signal. Here, this x of t represents this x represents the name of the signal. Name of the signal, and the t represents your independent variable. This x of t is your name of the signal. Here it carries some information. Even we used to say your noise also as a signal, but it doesn't carry any information. For example, the phone call receiving for me is an information for me, but those who are near me, it looks like a noise signal. In voice signal, the signal can able to bear the decibel of our human ear can able to bear the decibel of only 60 to 100 decibel. Even 100 decibel is also a lightly heavy signal. More than 120 decibel we call this a noise signal. It carries the information, but it is an unwanted information. We call it as a noise signal. This x of t, this is a graphical representation of the signal. We can define mathematically as x of t is equal to 5 sine 2 pi t. This is the mathematical representation of the signal. Here this x of t represents the name of the signal. As I already told, this x represents the name of the signal. This x of t represents your 5 sine 2 pi t. So it is a sinusoidal signal. Your x of t is a sinusoidal signal. This is the name of the signal. What information it is carrying? It carries some information. Your signal should carry some information. Here it is carrying a signal with amplitude 5 volt. It carries the amplitude with 5 volt and the frequency is 1 hertz. And the frequency is 1 hertz. A signal that carries an information. It's the physical quantity. It is carrying an information. This we call it as a signal. Let's next see what is system. System is the combination of a hardware device. It is the combination of hardware device used to process the input signal. We used to call this input as a excitation and the output as a response of the system. We can represent as a hardware system. This is your system. This is your input signal x of t. X of t is your input. I am naming my signal x of t as input signal. We call it as a input signal or excitation. And the output we call it as y of t, that is response of the system. So, your system is a combination of hardware device which is used to process the input signal to produce one output. We call it as a response of the system. So, now we have a clear idea on what is signal and what is system. So, I have told you the input signal. We can represent the signal in two ways. One is your continuous time signal, another one is your discrete time signal. Now, let us see what is the type, what are the types of signal. Depending upon the independent variable, we can represent the signal as a continuous time signal, that is CT signal, continuous time signal. Next one is your DT signal, discrete time signal. First, let us see what is continuous time signal. The name itself says it is a continuous time. The signal is continuous with respect to time. I am representing my signal as x of t. The signal is continuous with respect to time. That is, we can measure the voltage of the signal at any instant of time. All the places at any instant of time we can able to measure the signal value. These type of signal we call it as a continuous time signal. The next is your discrete time signal. Discrete means it is a discontinuous signal. The signal is discontinuous with respect to time. For example, we used to represent the signal as x of n t. This n is a discrete value. The t is your independent variable time, discrete time. Here you can able to measure the signal only at a particular interval of time. 1, 2, 3, 4, 5, 6, 7. Only at a particular time interval we can able to measure the signal at 1, at 2, at 3, at 4, at 5, at 1.5. If we want to measure the value of the signal at 1.5, we can't able to measure the signal. So, only we call it as a signal as a discontinuous signal. Only at a particular point we can able to measure the signal. We can see example for this continuous time signal is, as I said, our signal what we are measuring in an electronic devices. It is a time varying with voltage or current. Time varying signal with voltage or current is an example of your discrete signal. Continuous signal. For discrete it is a sampled signal. The data we are collecting in our data sheet. All these were example of the discrete signal. That's we call it as a sampled signal. These are the two types of signal. The signal plays a very important role in systems. Without this signal we can't able to process any system. Depends upon the signal also your system will be classified. Depends upon the signal. For example, if you are using a continuous time signal, the system should also be a continuous time signal. Your discrete time signal, if you are using a discrete time signal, your system should also be a discrete time signal. We can't able to process the discrete time signal in a continuous system. While giving your definition, I have told generally it is as a system. If my input is x of t, then my system is also a continuous time system. Then only I can able to get a continuous output y of t. In case if I am using a discrete input value x of n t, my system is also a dt system. Your output will be a y of n t. Depends upon the signal only we have to choose our system.